through projects. In this video, we are going to explain about the project title Data Analytics in Mental Health Care. Introduction. Mental health encompasses an individual's emotional, social, and psychological well-being, significantly influencing thoughts, emotions, behaviors, and relationships. It's vital for effective coping with life's challenges, maintaining productivity, and contributing positively to the community. By employing machine learning, specifically the random forest algorithm, on patient data, the project aims to precisely identify mental disorders such as bipolar and unipolar depression. This technology-driven approach enhances diagnostic accuracy and supports improved treatment strategies. Existing mental health diagnosis heavily relies on clinical assessments, which may introduce subjective biases and potential delays in interventions. These limitations could impact mental well-being by delaying necessary treatments. The project proposes a system leveraging machine learning to predict mental disorders based on past patient data. This data-driven approach seeks to elevate diagnostic accuracy, prioritize mental well-being, and facilitate timely interventions for enhanced patient care and well-being. Objective. The project's core objective is to implement the random forest algorithm in machine learning to identify mental health conditions such as bipolar disorder and unipolar depression. This technique is applied to patients' medical history data to predict and diagnose these conditions accurately. By utilizing historical patient data, the algorithm learns and detects patterns or correlations relevant to specific mental disorders. This training process allows the algorithm to recognize indicators within the data that signify different mental health conditions. Big Data Spark technology is integral to the project's success, ensuring efficient handling of extensive medical data sets. Spark's capabilities facilitate rapid data processing, enabling the analysis required for implementing sophisticated machine learning algorithms, ultimately enhancing the accuracy of mental health predictions. The project aims to support healthcare professionals by extracting valuable insights from historical data. These insights guide the formulation of more accurate and tailored patient care and intervention strategies in the realm of mental health, ensuring better informed decisions for patient well-being. Software and hardware requirements. Hardware requirements of the project are: operating system is Windows, processor is i5 and above, RAM is 8GB and above, ROM is 25GB and above. Software requirements of the project are: application is Python IDLE, primary language is Python, front-end framework is Tkinter. Methodology. To implement this project, we have designed the following modules. The first module is Upload Dataset. This module allows users to input and upload the dataset into the application. Users can select the relevant file containing the necessary medical history data of patients to be used for training and testing the machine learning models. Read and process dataset using Spark. Using the Spark framework, this module reads and processes the uploaded dataset efficiently. Spark's capabilities help handle large volumes of data, ensuring rapid processing. It converts non-numeric data such as age groups or educational levels into a numeric format suitable for machine learning algorithms. Split dataset into train and test. This module divides the dataset into two subsets, training and testing data. Typically, it allocates a significant portion, example 80% for training the random forest machine learning model, and reserves the remaining portion, that is 20%, for testing the model's accuracy and performance. Train mental illness data with random forest ML machine learning. Here, the random forest machine learning algorithm is applied to the training dataset. The algorithm learns from the historical patient data to recognize patterns and relationships associated with specific mental health conditions, ultimately creating a trained model. Upload test data and predict mental illness. This module allows users to input new patient test data that lacks specific mental disorder labels, AFF type. The trained random forest model then predicts potential mental health disorders based on this new patient data. Accuracy comparison graph. After prediction, this module generates a graphical representation, typically a graph or chart. It displays the accuracy and error rates of the random forest machine learning algorithm. The graph helps visualize and compare the accuracy of the model's predictions against the error rates, demonstrating the model's performance. Random forest. In this project, we have utilized random forest. The random forest algorithm employed in data analytics in mental health care utilizes historical patient data to create a group of decision trees, identifying complex patterns associated with different mental health disorders. This amalgamation of trees allows accurate predictions of disorders in new patient data, improving diagnostic precision for effective healthcare interventions. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. Importing this dataset contains the information of number, that is patient identifier, days, that is number of days of measurement, gender, age, AFF type, that is bipolar or unipolar depressive, marriage, work, etc. This is the main code file. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. This is the graphical user interface created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Dataset button to upload the dataset. Select Mental Illness Dataset and click on Open. Here we can see that the dataset is loaded and this is the location for the dataset. Now click on Read and Process Dataset using Spark button to read dataset using Spark Python API. So here we can see dataset loading process completed using Spark. Now click on Split Dataset into Train and Test button to divide dataset into Train and Test part. So here we can see total records found in dataset is this much, and we have split this dataset into Train and Test, where training dataset size is this much and testing dataset size is this much. Now click on Train Mental Illness Data with Random Forest ML button to train random forest with the above dataset. So here we can see after training random forest, we got the accuracy, which is this much. Now click on Upload Test Data and Predict Mental Illness button to upload test data. Now select the test data and click on Open. So here we can see that this is detected as unipolar depressive disorder and this mental illness is detected as bipolar 2 disorder and this is detected as unipolar depressive disorder. Now click on Accuracy Comparison Graph. So here on the x-axis we have the algorithm name and on the y-axis we have the accuracy value. And from this graph, we can say that random forest ML prediction error rate is less compared to random forest ML prediction accuracy. Now close the graph. Click on Exit button. Conclusion. By training on historical patient data, the random forest algorithm effectively predicts various mental health disorders like bipolar and unipolar depression. Its ability to identify patterns within the data results in precise and reliable diagnosis, aiding healthcare professionals in understanding and categorizing mental health conditions more accurately. The utilization of Big Data Spark technology facilitates rapid handling and processing of vast data sets. This capability is crucial, especially in the context of machine learning algorithms, as it accelerates data analysis, ensuring timely insights from the data. Applying the trained model to new patient data lacking mental disorder labels demonstrates the algorithm's effectiveness in predicting various mental health conditions. This capability assists in timely diagnosis, enabling healthcare providers to initiate appropriate treatment plans promptly. The successful execution of this project signifies a significant leap in mental health care. It introduces a data-driven approach to diagnosis, allowing for precise categorization of mental health disorders. This advancement offers the potential for tailored and personalized patient care strategies based on data insights, improving overall mental health treatment methodologies.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.